Thank you. I want to thank Hacking the Box for this opportunity to allow me to speak in this COMMSEC track. So we will start right now. Yeah, in the trail of WINDSHIFT APT. Just a little bit about myself. I've been doing reverse engineering for the last decade, mostly malware. I've been working with previous companies like FireEye, Symantec. So I've been doing this APT malware for a long time, and this is something very unique, kind of different from what we see usually from commodity APT groups, and hopefully you will enjoy this talk. So let's start about APT myths and definitions before. So you might think that APT means always something that is always advanced, that use some stealth tools, but let's take it this way here. Actually, an APT is as advanced as their target. If the target is not very secure, or if it's a small company, they're not going to use their top secret tool. They're going to use probably something that is very simple. Let's take a target that's running Windows XP with absolutely no AV. The advanced APT will not go there and burn a 0-day or burn an implant, but he's just going to use probably a pony stealer, and he will still be able to exfiltrate the information. So APT doesn't mean always advanced. That's the point I'm trying to make here. Also, I come with this diagram, I would say. This is what I use to measure if an APT actor is advanced or not. We have three things. We have the OPSEC, success rate, and the detection. So OPSEC usually is very important, obviously. And this is something that we can measure an APT with. For example, if an APT have a very bad OPSEC, let's say registering some domain names, and you can just do a whois and you see the email of the person who registered the domain, that's obviously a very bad OPSEC. But if you see an APT actor who's changing from an infrastructure to another and registering the domain in a way that you cannot see, anonymous way, and also they evade all kind of tracking, they leave no trace behind them, that's obviously an APT with a very good OPSEC. Same goes for the success rate. Is this APT was able to persist in your environment? How they were able to exfiltrate information, the reach, how far this APT went inside your network, what type of information this APT got from your network. Also is also related to detection. Detection is, are they noisy? Do they create alerts inside your environment? Or they've been there for 2 years with 0 alerts, right? So this is what I'm using, me personally, from my experience, to measure who I'm dealing with. Is it like an advanced one, or just commodity type of APTs, right? So as you know, Dark Matter, we are a cybersecurity company in the Middle East. We are lead in the region. We are lead in cybersecurity. And we usually publish a lot of research, white papers, around APT targeting the Middle East. Some examples here, we have Greenbug, Oilrig, Muddy Water. If you follow in the Middle East, Westend, these names will, you probably heard about Greenberg, Oilrig, so those are like very known, famous, I would say, APT targeting the GCC region. Most of these APT will rely on open source tools. We call them like copy-paste actor. There's a huge one called Patchwork, who they just use open source tool, nothing else. So they do that in a way that we cannot track them easily, and we don't know who is behind it. Some of them, they're gonna use a custom tools. They're gonna use their own they program their own implant, their own backdoor, and this is where it's getting exciting, because it means that these guys have a couple of developers, they have project management, they have, they need to follow SDLC programming, they need to be, port their sample to be able to run all type of versions of Windows, for example. So when we have this type of adversary, we're probably dealing with a real APT with a very noticeable experience level. Once they have their custom tools, they actually unlock the glorifying lifetime APT attribution. So all now, everyone said, okay, this is APT 28. Yeah, so if we go back to our actors in the Middle East, we have ORIG. So ORIG, they use Mimikatz. Who knows Mimikatz? Okay, a couple of people. So Mimikatz is a very known tool if you guys doing pen testing, offensive, red teaming. So that's the tool that we usually use to do some privilege escalation, to create some golden tickets and things like that. So what these guys did, you take Mimikatz from scratch, compile it, you throw it on an environment, it will get detected. So what these guys did, they took a very old version of Mimikatz, and actually what they've done, they just changed some strings, because obviously Yara detection is a static detection, and most of the time they do detection of strings. So here we see at your left, this is the original Mimikatz. At your right, the custom version of Mimikatz that ORIG used. And as you can see, there were just some string replacement. They changed the strings with no obvious ones. And that was enough to bypass a static detection. It works like that, but yeah, it's actually working. Similar another function that I found, and actually I just doing the diff of this assembly, and you can see that clearly it's the same function, but the strings are changed. So why and how WINDSHIFT APT is different? So why I'm saying it's different, why it's a big deal, why I'm talking about it? Very simple. It's a pure intelligence, cyber espionage actors. They are after individuals, right? They're not after companies, they're after specific people. So they're gonna choose one person, they're gonna hack her or his personal emails, and from there they're gonna exfiltrate as much information as they can. They also use other actors' malware. So it's very hard to work on attribution piece because these guys are reusing other malware that is flagged as part of other groups. And they rarely directly target with malware. They usually do spear phishing the whole year. And once or twice a year, they're gonna approach someone with a malware and they're gonna try to infect the target. But they take a lot of time to do that. And the fact that they are going after specific individuals and not companies, I mean, that's what helped them stay under the radar for a long time. Because personal computers, usually they don't have security solutions. And even if they have, you just click on block or put in quarantine and that's it. While if you have a trigger in a company, then it's gonna alert the SOC, then you're gonna call the incident response, they're gonna do investigation. So this is basically how they stayed under the radar. Let's talk about the MO. So these guys actually, well, we don't know from which country they operate from, but I'm gonna explain you all the phases that they use. And we're gonna talk a little bit about attribution at the end. So the recon phase. That's actually the first phase, it's the longest phase, and actually they maintain a couple of fake personas. So they have fake LinkedIn accounts, Facebook, Twitter, Instagram. They are all over the place. So what they're trying to do is they're trying to get the first contact with individuals in order to get their email address or their phone numbers or their contact list, whatever. They also develop sometimes apps on the Play Store. These apps were stealing information such as contact lists and reading your SMS. So this is an example of one app that we found, and we published a blog about it, and we asked Google to shut down the app from Play Store because this app was malicious. An example here. It's a very funny because it's actually the same person with the same picture, and it have different accounts. Facebook, Twitter, Instagram. LinkedIn. As you can see, the LinkedIn account have more than 500 connections. Actually, what they did, they took a picture of a legitimate person, and using Google Cache and things like that, we found that this person is living in Latin America. She had nothing to do with this, but they took her picture and used them to attract people and to approach people, right? But something very interesting is the Twitter account. Because Twitter, if it's not private, it's public, so you can see all the tweets. And there is a very nice tool. This is our OSINT 101 on Twitter. So there is a tool called Tweet Analyzer by Xors. So shout out to Xors if you're watching. You run it against a Twitter account, and it will tell you the weekly activity of a certain Twitter account from the start. Now for this Twitter account, she tweeted about 200 tweets for the last 2 years. And something very interesting is Friday, there was absolutely no tweets, so which is not normal. If you take a legitimate Twitter account, let's say the Grug, if the Grug is here, or Matthew Swish, these guys are posting every day. So clearly, you won't see a gap here. And actually, this gap tells us something. It's not a coincidence, but it tells us that maybe the person operating this Twitter account is in the Middle East. Because in the Middle East, as you guys probably know, we don't work Friday, right? So I don't know if it's a coincidence or not, but this is what we found, right? So this is something you guys can do if you investigate in Twitter accounts. Sometimes if the guys are dumb enough, they put the geolocation on their tweets, so you can easily flag on which country they post the tweet. But otherwise, you use stuff like this to obviously see from where these guys are operating. Just an example. Second phase, they actually approach people via LinkedIn. They ask you for an email address, personal email address, Gmail account, and they start sending you emails. And within the emails, there's a tracking code that they use, and they can see from where actually, first of all, they see if you open the email. They can see also from where you opened the email, like your geolocation. And they use like regular emails like this one. So they just copy paste content from local media. And they send you an email like this every day. They send you an email. And they're watching your click habits. So they create some relation with you without you knowing for the long term. So these guys are playing for the long term, right? It's a very long-term campaign. And within this email, this is the source of the email. You can see like there's a, what's my email read? Blank.gif file. And as soon as you open this email, they receive this type of notification. They know your IP address, your user agent, so they know what operating system you're running. And they also know, I just hide it, but they know your location. They know from which country you open the email. It's actually very dangerous because they send in this every day. So basically, every day they know where you're at. It's kind of some type of tracking that is very dangerous. After that, they move to the credential harvesting. So what they do, once they build this relation with you, once you know they always send you emails, sometimes they're going to send you an email telling you that your password, you need to change your password, regular spear phishing. But they do it in a certain way that is very targeted and very legitimate. I mean, it's very hard to detect if it's a fake email or not. And they also use domains where they host their spear phishing platform. They register domains with Freenode. So Freenode is a free service. You can just go there and register an email. And as soon as they register the email, the spear phishing, they shut down in one day. Like basically, they register a domain, point it to the spear phishing platform. They wait for 24 hours, and they shut down the domain. They create another one, which make them very hard actually to detect by spam hosts or those spam filtering engines. They also use legitimate SSL certificate. So they go and they buy, actually they either use free SSL or Let's Encrypt, or they even buy real Komodo certificates. An example. That's, for example, for Outlook Web Access. So they send you this email with your real email address. Here it's configurable, so they can put your real email address and tell you, hey, your account got compromised, blah, 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 change your password. They also do it using the cloud, iCloud, but if they know you have a MacBook or iOS, they send you this, right? They also send you SMS. So everything looks legitimate. Here, an example with Etisalat. So Etisalat is one of the biggest ISPs we have in UAE. And this is clearly an email, SMS they also send to your phone. You click on it, you are redirected to this page, and you give away your information. As you can see, HTTPS, real certificate. So 24 hours later, they shut down the domain, and that's it. If you do an investigation, someone sends you the link. If you look at it the day after, it's gone. Right? So they really know what they're doing, and they've been doing it for years, and nobody actually noticed. So it's very, very dangerous. Here is an example with Gmail. And they scare you, they tell you, hey, if they know you from certain countries, they say, hey, your Gmail account was opened from Iran, from Tehran. Click to change your password. They say, oh my God, my email got hacked. You clicked. And actually here, it's their own spear phishing platform. It's a custom tool they use, they built. It have HTTPS. And here they put automatically your email with the base64 in URL. So you can clearly see the type of, it's a kind of advanced type of spear phishing. It's not something that you can easily flag. Okay. After that, this happens once or twice a year. And this phase is really when they are desperate, when they cannot get to your email, and they really need to access your computer for some reason. They're going to do the hacking target. So this is the phase where they actually use malware. And this is how we found the macOS malware they'll be using. It's such a big deal because, a macOS malware are not 100,000. There are like probably 100 or 200 known families today. And this is kind of new type of malware they use. I'm going to talk about it later on, but they use that. They send it to you via emails. I'll tell you the infection vector, how it works. And what these guys did, they put a real separation between the command and control servers and the spear phishing infrastructure. Why? Because if they host the command and control server inside the spear phishing infrastructure, if the malware got detected, then you can trace everything, you know where is the spear phishing, you can start doing your threat intel. But the fact that it's completely separate, they keep the spear phishing very away from the command and control servers. So even if the command and control server got compromised, they still have the spear phishing, nobody knows where is it. So this is how they do. And actually I traced all their servers. Their infrastructure, as you can see, there's a real separation between the command and control and the spear phishing infrastructure. There's a real separation between the two. The last phase, they disappear. As soon as they do the attack, they go away. How they go away? They change providers, VPS providers. They probably hack into other servers. So we don't really know how they get the access. So I did some analysis on the type of VPS. They usually prefer the VPS that use Bitcoin, so probably to make them stay anonymous somehow. Or they go and use some bulletproof hosting services, so providers. So this is something they do every 6 months. So they use infrastructure, they shut it down, they move to another one, et cetera, et cetera. So that's why I call them WINDSHIFT, because I didn't find any other name. So they're actually very hard to track. Which means they have people behind it. They have people who manage the infrastructure, they have people who manage the malware, they have people who send the email, they have people who manage the Twitter account. I mean, it's a huge company who's behind this. Here's an example. They were, for example, operating on Wildcard, and then they moved to Buddies LLC. So Buddies is a kind of a playground, very known. If you know about Dark Hotel, they were hosted in Buddies LLC. So this is only for one particular domain, as you can see. Let's talk about the tool set. Dark Matter uncovered a couple of macOS samples. So I'm gonna go through each of them and trying to explain like how they work, etc. There is a very last one here. It's a Windows malware. It's actually just a downloader. It downloads the unknown malware. So the unknown malware is actually the second stage, and it was removed from the C2 server. So for now, it's unconfirmed, but the four others are confirmed. I'm gonna start with the first one. So this is WinShell. It's a signed macOS malware. Signed means like gatekeeper would just say, okay, you can run, no problem. So it's a developer's, signed with a developer ID. This malware will go after this file with certain extensions, and then it will exfiltrate them. The persistence is done via login items, and actually they use ES256 ECB to encrypt the strings. The ES key is hard-coded inside the sample. So the first operation of this was in 2017, and the infection vector, what I'm gonna talk about it, is they use a spear phishing email with a link that once you click on it, it's gonna do something very uncommon, I would say. Before going into that, here is the email that they sent you, the source of the emails. As you can see, we can still find the was my email read. They can always track what you do. And the malware comes as a image stored into a Google user account. And once you click here, you have a specially crafted web page. So the specially crafted web page, what it does, is very sneaky. So actually, they give you a zip file to download. And Safari, by default, if you have a zip file, it will automatically extract the file and store it in your file system. And they call a URL scheme here. It's a custom URL scheme. They call right after. And they repeat that every 3 seconds. What does it mean? It means that this malware here has some sort of custom URL scheme in it. So once you download it, if the page is still running, it's going to automatically launch this malware using the custom URL scheme. The thing is, they did a little typo on the URL scheme. So thankfully, the attack didn't work because it was here open URL. They missed the L, and it didn't work. But, so yeah, first attack actually failed, but the other ones didn't fail. The one that came after, but this one from 2017, I believe that was their first attempt. Yeah. Okay, so I'm just gonna tell you why this worked. How come just by downloading a file, you can open a browser around the file? How come? I have a video here. I'm gonna, yeah. So actually, there's something called launch services database. So launch service database is a daemon that runs. They have a launch service, it's a daemon, and actually as soon as you see a new file, it's gonna store all the information about the file, including the custom URL scheme. Whether the current user is admin or not admin, the custom URL scheme will get stored inside the launch service database. So here, just showing that it's not an admin user, it's a normal user. And there is a binary called ls register on Mac. This binary will just dump the launch service database. Yeah. So as soon as you find it, because actually it's in a path somewhere, so I always do a find command. I can't remember the path. So now I'm going to dump. So it dump all the launch service database. I'm looking for the custom URL scheme. Didn't find it. Now what I'm going to do is I'm going to just put the malware inside the share. I'm just going to browse through it. nothing else. So I browse to it, that's the malware. Do again, here you go. It registers itself to the launch service database without any user interaction. And yeah, it's signed, so here we're checking just a signature of this malware. As you can see, it's signed with a Apple developer certificate. Problem with this is now we're gonna do as the web page, we're gonna run our browser and just type in the custom URL scheme. And you will see the malware will just launch itself. You can put whatever you want to put there. You have a user consent pop-up that tell you, are you sure you want to run this file? And you open, say yes. So the name of the file is controlled by attackers. So if the attackers name the file as Safari or Mail, most of users will get tricked and they click on yes. So here it's running. So yeah, that's actually the technique they use. So on Windows, this is not possible because on Windows you want to create a custom URL scheme, you need to be admin. You need to be admin to add a custom URL scheme, and you need to do it by hand. You need to add a registry key under HK class root. You need to add a key there, and you need to be admin. But on Mac, you don't need to be admin. So that's actually the technique they use. Yeah. Something interesting about this sample is it looks like one of the samples from 2012, which is a surveillance malware. So I went all these samples from 2012. Actually, I found some code reuse. So the code that was reused here was a function helper function that was the last 8 bytes of a file. And I found the exact same function on this new sample, which is a sign of code reuse. It means this guy, for some reason, they got access to the source code of a malware from 2012. And the malware from 2012 was, there was an attribution by Norman Group, and they said this is part of Operation Hangover, or APT Security, which is an Indian company doing offensive type of work. But it's from 2012, and actually these companies closed the business. It doesn't exist anymore. But these guys have this sample, they have the source code, they modify the source code, and they reuse it again to hack into governments. So it's kind of unusual, I'll say. WinTLB is a second variant. This one is very simple. They just send it as an email attachment. That's pretty much it. It has similarities with SOFACI APT. You know, there's a complex OS6 malware they used. And this one, they actually used a reachability framework to test if google.com can reach to google.com. It's a way to test if the internet connection is working. Actually, they use the exact same technique here in this sample, which is kind of strange. And complex OS6 are being hosted in AutoHost BV, which is a provider in Netherlands. And actually, Hangover 2 was hosted within the same provider in 2012. So we probably start seeing something right now, but there's clearly a relation between the two somehow. So we have WinTape. So WinTape is another malware, but this one takes screenshots of the user. So basically, it's downloaded by WinTLB, the previous sample. That's the HTTP request. Downloading the WinTape. So WinTape, what it does, takes screenshot, send the screenshot to the C2 server, remove the screenshot, and repeat. That's what it does. So it's constantly taking screenshots of your desktop and sending the image to a C2 server. It's kind of funny because we found some classes written in Farisi, so Farisi Persian language. We found, for example, Goli. So Goli in Farisi means flour, and Namak means salt. So it's kind of very strange that we found these name classes written in Pharisee. So it looks like someone trying to, work on kind of false attribution or make us believe that some Persian-speaking actors are behind this. The string encryption for this one was just using DES with an IV. So I just wrote the Objective-C using CC-Crypt to decrypt it. A small demo showing this actually malware taking screenshots. Wait, full screen. Okay. What? Yep. Yeah, I got it. Thanks. Full screen. Yeah. So the malware name is LSD. It's in desktop, as you can see. It's here. It's here. So I just double click on it. And watch carefully what happens. So it's going to persist inside user library lsd.app. This is where it persists. And actually, it goes to the bundle resource folder. This is where it's going to store the screenshots. So watch carefully here. There's the screenshots, and then disappears. It's going to come again. So every 5 seconds or so. He's here, he's gone. So I tried to copy it, but, so I'm going to copy it now. So as soon as it appears, I just try to copy it. Yeah. Double click on it. And as you can see, it's a screenshot. So what happens to this screenshot actually is, I'm going to just send another video here. Yep. And you will see that the screenshot is actually sent to the C2 server right away, and then it's removed. So it's kind of a big deal because we never see something like that till now. Like, no other malware does this. So it's kind of something new, actually. And also, people need to see this in real life so they can understand the impact of this. So as you can see, all these post requests are all sending the picture, as you can see, to the C2 server. All right? So that's a real-world example that I just show you here. One last note about this macOS malware, they all use hard-coded ES key using UTF-16 Little Indian. So not UTF-8, UTF-16. And they use some sort of Danish keyboard to write those type of characters. But those are the hard-coded keys that were found on each of these samples. That's the Windows variant that we found. WinDrop is actually a Windows malware talking to the same C2 server as the other macOS malware. So the same C2 server talk to Windows malware to macOS malware. And this one, what it does, it's when it's run, it took all the information, current user, path, etc., send it to the C2 server, and then it downloads another stage. And we were not able to figure out what this stage is because it was removed from the C2 server, but this is something we're currently working on. That will be the tool set. For this particular malware, the Windows one, the decryption routine was kind of different because it was using a standalone function that does the decryption. So figure out why not we can, so that's the function actually, and it's the same function called everywhere to decrypt all the strings. So I was figuring out why not just doing emulation. Because you don't want to spend a lot of time, and sometimes when you're analyzing something, you need to have answers within the day. So sometimes you don't need to go through all the decryption function. So you just need to emulate it and see what it does. And there are some people who does that with Radar. And I thought it's a good idea to do it in Binary Ninja to be kind of different from other people. So we're gonna decrypt the strings of this malware using Unicorn Engine, using Binary Ninja, Reaper, and some ninja skills. Well, you'll say this, it's not really ninja skills, but you know, it's still, okay, full screen. Sorry. 1 second. Yeah, here. Full screen. Okay, so that's the binary. It's a regular PE file, x86. Yeah, that's basically the entry point. And actually, you see that's the encrypted strings, and it goes through the same function. So the same function does the decryption. And the function is here that does the decryption is standalone function. And actually, the value, the current pointer on the string is on ECX, and it does some operations on the current character depending on a value that is EX. So depending on that value, either they decrement ECX, either they add 3 or they subtract the value. So we can clearly, since it's a standalone function, we can clearly emulate this function and be able to decrypt the strings without the need to rewrite a plugin in either Pro or whatever to decrypt, to write the algorithm to decrypt the string. We can just emulate the function and job will be done. So here, we're gonna use Reaper. So Reaper is a very powerful Binary Ninja plugin. What it's gonna do is gonna generate a Python class where, well, here it looks kind of scary with a lot of code. So what it does is take the code section, the data sections, map them in memory, set the protections, and then set the entry point and start the emulation. That's what it does. So I'm gonna close this file and open another one using Sublime. Yeah, this is more readable. So as you can see, you have the code section, data section. What it does is just gonna, map them in memory, write them there, change the protection, execute them. That's what it does. As you can see, the memory address of the start is 404010, is exactly the same one. I'm gonna start the emulation. But something very important is we can do actually hooks for every opcode that is executed. So every time you see an opcode, you have a hook. And you can do whatever you want, whatever operation you want. So there's a function called hook code. So we just need to declare this function. It's a virtual function. So we need to create another class, inherit from it, and define the function, and then define whatever operation you want to do there. And we have done this here. So we define hook code. And actually in hook code, what I've done is as soon as I see a return, it means that I finished the decryption. And since I know it's in ECX, so all I have to do is dump the value that point ECX minus the length of the strings. Because actually the string got decrypted in memory, but it stays the way where is it. So I just need to check ECX, subtract the length, and dump exactly this memory address, and I'll have the decrypted string waiting for me. So this is all what I've done here. It took me like an hour to write this, but I'm sure if you have a template, you can reuse it for any type of function, and you're not gonna spend too much time doing it. And here, I'm just gonna run this Python class, and you will see the results. So I put here this assembly. I will run the Python code. That will do the emulation for you. I did some pretty printing to show you like the results. As you can see, in blue is the encrypted string. In yellow is the decrypted one. There you go. So actually it worked without having me to understand the decryption routine. I just see from where it starts, from where it ends, did the emulation, and dumped the ECX. Yeah. All right. Go back to the slides. Attribution. So what I mean here is we have an actor using a source code from a malware dating from 2012, reusing it today. The company that runs the malware actually closed, is out of business. So it looks like either this actor actually hacked into the servers of this company, or bought the source code, or someone working at the previous company sell the source code to these guys. But clearly these guys are reusing the source code, because even on the last variant that we found, we saw signs of modifications and signs of code changes. It means that these guys really have the source code of this malware. We also did some analysis compare with what happened in, with other actors. There's an actor called the Bahamut APT. So it's tracked by Bellingcat. Do you guys know Bellingcat? So if you do threat intel, cyber espionage, you know who is Bellingcat, Citizen Lab, Bellingcat, all these guys, they're doing great stuff. So these guys are tracking Bahamut APT. And actually, for some reason, we found the exact same MO as these guys. So at your right is WINDSHIFT APT, at your left is Bahamut. As you see, they're using the same type of MO. They send you an email with tracking news, some content. They duplicate content, send it to you from a Gmail account. They also have their LinkedIn account as well. It's kind of similar. So that's the WINDSHIFT, that's the Bahamut. They also send SMS, same as WINDSHIFT, so they're using exactly the same techniques. Okay? And Bellingcat, they went through all the, this was a while ago. So the guys did a mistake, OPSEC mistake, and they left the email address inside the registered domains. So these guys were able to recover all the email addresses. And that you're gonna see something here, they always use an English name followed with a number, right? If you see there, WINDSHIFT, it's kind of the same. English name, like Karim Van or Warren Port, and there is a number. So it's kind of mail.com, mail.au. So there's some kind of similarities right there. To conclude this talk, so APT insecurities from 2012, they probably got highly likely either targeted by WINDSHIFT, or they have their tools stolen by a rogue employee, we don't know, or the tools were sold to a third party. But we have facts. The fact number one is the APT insecurity tools are reused now today to hack into governments. The fact number two is we found a lot of overlap with existing APT actors, Bahamut, Sofasi, etc. And the fact number three is WINDSHIFT APT are currently targeting governments using APT insecurity tools. So that's pretty much it. That's the research is about. And in the next weeks, we're gonna publish a blog about a technical blog. So we're gonna just document all the samples that we found. We're gonna provide detection rules. We're gonna provide disinfection routines and things like that. We're also gonna publish a MacBook lockdown guide that you guys can use to lock down your MacBooks. So here are some references if you guys are interested. And I would like to thank you for your attendance. Thanks. You guys have any questions? Or
thank you for your talk.
Thank you.
Are there any questions from the audience?
Yeah.
Hi, my name is Karim. I want to ask, for the sample that was taking the periodic screenshots, was the traffic, you went on to show the Wireshark traffic, right? Was the traffic
It was
encrypted?
detected.
Oh, was it encrypted?
No, actually the beacon was hard-coded in the sample. And the sample that was sent was a zip file. So there was absolutely no encryption at the network level. So the screenshots were sent in clear text. The download second stage was downloaded inside the zip file. That's all. So, and the files that are exfiltrated are sent inside zip files. So they send a zip file.
Okay, thanks.
Yeah, no encryption.
Thank you. My question was about, so you said that these guys only operate once or twice a year. I mean, they try and compromise someone once and twice a year, and the period in which they plan the attack is, is measured in years, like 1 to 2 years. And you also said they target individuals and they don't target companies. Yeah. So it's easy enough to understand why these groups attack companies. There's a lot of value to get from these type of attacks. But do you have any information about why the type of people that they're targeting? Because it must be a very specific profile that they're going after for it to be worth it. Otherwise, if they're hacking a couple of average people per year, it wouldn't really be rentable. So I don't know if you have any information about what kind of people they're going after and why.
Yeah, so I can't say much about the people they're targeting, but those people have something, they work at certain entities, right? Mostly government, so they are looking after these people. We had a case where one person opened the personal email account inside the corporate environment, and actually downloaded the malware inside the corporate environment, and they were able to exfiltrate these files.
So I mean, this individual created a personal email and used it at work, for example, or in the office, and
I cannot say much about it. Yeah, but
okay,
it's an individual that was targeted. There was approached via LinkedIn, and that's how they actually approached this person, and they were lucky enough to have this person open her personal emails inside the corporate environment, so they were able to get corporate files as well.
It just seems that the reward to risk ratio that is very unbalanced, to where, like, if they don't actually get to their target, but because it's not a mass targeting approach, they're very specific about who they target. If they miss their target, all the resources they put towards compromising that person sort of goes to waste, in a sense. So
I think from their MO, it looks like they have all the properties of a state-sponsored type of actor, okay? These are not amateurs or guys sitting somewhere in a cave doing their things. This is like a sponsored, state-sponsored adversary. So they have a budget, they have resources, and they've been there since 2016, and they are in the long term, and they are very persistent. So they're gonna spend the whole time needed to get inside a computer of a certain target, either by using spear phishing for a long period of time, or if they are hopeless, they're gonna reuse another malware inside to target this individual, so that even when we found the malware, it's not easy to do the attribution to them. As you see here, they use malware of another actor. So they really know what they're doing. And they have a very, very good OPSEC. And as I said, they work for the long term. They don't mind spending 1 year. There was a case where they literally spent 1 year to get inside one target computer. They took 1 year. So 1 year of emails, tracking, spear phishing, credential harvesting, didn't work. And then one day, they send an attachment with the link, and so yeah. I think they have budget and they have resources, and yeah, it happens.
Thank you very much.
Yeah, no worries. Thanks.
Are there any more questions?
Sorry, another question here. So this is relating to the sample that had a typo in the open URL, the missing L. So I'm curious, when these any kind of threat actors like these test their payloads, do they generally test it before they send out? And also when they do, it's like a second follow-up question, like when there are historical DNS resolvers or records, has there been any APT groups have been tracked based on like the initial testing that they have done? and the DNS resolutions was captured. And this because this is related to the concept you're saying, they keep their spearfishing infrastructure and the other infrastructure used to generate all these payloads on very different. So has historical DNS, like while people are testing the initial payload, been used to track the origin of?
So for this particular actor, I didn't see anything documented or a company who went after these guys, because these guys are actually very specific to the GCC region, in particular the UAE, okay? So from that's the fact that other US companies or other big vendors, security vendors, won't probably track these guys. And since these guys are targeting personal computer, most of these personal computer, it's MacBooks, they probably don't have an AV. So if you go check on VirusTotal, you will not find the hashes at all. So those are completely unknown hashes. We are in possession of these hashes, and we are currently working on them. But from my understanding, is there is no other company who know about this actor. The second fact is this actor is looking after personal computers, so which means they're not targeting corporate environment. If they target corporate environment, they're gonna leave traces. They're gonna leave samples. So IR will take the samples, we probably upload them, some just upload them to VirusTotal. So until now, nothing was disclosed about this actor. And we are not aware that there's another vendor who's tracking these actors. So yeah, now for the mistake they did on the open URL, the URL scheme. I'm not really sure what they did the mistake. It happens because sometimes they work on under pressure. For example, somebody told them, okay, we need to send an email right now without even testing anything. They probably did a mistake there. It happens. So this is clearly a mistake they did. And also not only, I found a couple of coding mistakes inside the malware. For example, it registered 2 times inside the login items. It's supposed to be doing only 1 time. Why? Because in the entry point, they put the persistence routine inside the entry point. So when the malware runs, copy itself runs a second time, it persists a second time. So there were a lot of programming mistakes. But the malware that it's from 2017, the version of WinTLB from 2018 is a complete rewrite. And they clearly did a lot of progress. And now the sample they have now with the LSD, the one who takes screenshots, are working perfectly. They don't have any mistakes in their code so far.
Are there any more questions?
Yeah.
Sorry, just now you have hidden that URL, so I couldn't see the URL. Did they is this attacker use any kind of typo squatting domains to redirect the users?
Sorry?
Typo squatting domains?
Cookies?
No, it's a typo squatting domain where like something like is google.com they change it to googles.com.
Oh,
yeah.
So domain typo squatting.
Yeah.
Yes. They do this a lot.
Yeah.
All the domains they do are domain typo squatting. So they're gonna use like Google with 2 L's or dash or whatever, and they do that a lot. They do that, of course, victims will not pay attention, so they will just click. So this is what they do. And this is very common in the Middle East. APT actors, they use a lot domain typo squatting.
In terms of copyright, we're having challenges as well to take down those domains.
So what we have done for this particular case, all these malwares were talking to 2 domains, and we actually took down the domains to work with the TRI, for example. So we blocked the access to these domains, and also we use that to identify who are the other victims, the way how we did it. So we focused on the malware command and control servers, because those are in priority more critical, because they are responsible to exfiltrate information. So the first thing we did is we shut down these 2 domains, and we worked with TRA to see who are other, individuals who are targeted, and we actually currently working on an investigation on this.
Just me.
Yeah, you're welcome.
Okay, that's all the time we have. So if you have any more questions or follow-up questions, please do not hesitate to ask him afterwards. Thank you again,
Thank
Taha.
you. Thank you.